In this video, we're going to look at how to name and draw aldehydes and ketones. So we'll start with aldehydes. The functional group of an aldehyde is called the carbonyl group, and the carbonyl group is simply a carbon with a double bonded oxygen. In aldehydes, it's always on the end and will be carbon number 1. So this here is the first member of the homologous series of aldehydes, and it's called methanol. And you can see here is your carbon double bonded with an oxygen and a hydrogen. It's written as HCHO. Now we have to show that it as a CHO group, because otherwise it would look like an O group or an alcohol. A solution of this particular aldehyde is called formaldehyde, and this is used to preserve biological specimens. In this, the second member of the homologous series, there's the aldehyde group, and there are 2 carbons, so this becomes ethanol, commonly known as acetyl aldehyde. And this is what gives you a headache if you have a hangover. This one here, you can see the CHO group as well, and this is called benzaldehyde. Now when naming an aldehyde, we have to name the parent chain first, and we find the longest chain containing this functional group. And with the aldehyde, it will always be on the end. So 1, 2, 3, 4, 5. Now you'll notice this one also has an alcohol group in it. Alcohols are not as important as aldehydes. And because they're not as important, they go to prefix. So the prefix for the functional group of alcohols is hydroxy. So counting this, we have 5. It's pentanal. Al for aldehyde. You don't have to put a number in because the aldehyde is always carbon number 1. We have a branch, and in that branch is a methyl group. So methyl, and that's on carbon number 3. And we have this hydroxy group, which is an alcohol group, and that's in prefix. So hydroxy. And that's on carbon number 4. So 4-hydroxy, 3-methyl, pentanal. Now I'd like you to try and name these aldehydes. You will need to stop the video, have a go at the question, and then check the answer. So here is our aldehyde group. 1, 2, 3, 4. So it's butan. Now let's have a go at naming this aldehyde. Stop the video and try it. So this will be our CHO group. It's on carbon number 1, 2, and 3. We have a methyl group. So this will be propanal, methyl propanal, and we have a bromo on carbon number 3. You'll notice I didn't have to put a number in for the methyl group because there's only one position it can be. Now try naming this aldehyde. Remember to stop the video and have a go. So the main functional group is the CHO group. So 1, 2, 3, 4, 5. We have a branch, which has 1 carbon in it, so it's a methyl. We have a chloro, a bromo, and a chloro. So it is pent, tan-nal, Al for the aldehyde. We've got a methyl group, and that is on carbon number 3. We've got 2 chloros, so it's a dichloro, which is on carbon number 2 and 5. And we've got a bromo, which is on carbon number 4. Now let's have a go at drawing an aldehyde. When you draw an aldehyde, always start with the main chain, which is in this case is butanal. 1, 2, 3, 4. We're going to put the aldehyde group on, which is the double bond O, H. There's the CHO group. We have, so this makes it carbon number 1, carbon number 2, 3, and 4. So on carbon 2 and 3 we have a dimethyl, so we have a methyl group and a methyl group. And on carbon number 2 we have a hydroxy group, which is an alcohol group. On carbon number 4 we have a chloro. Complete the drawing by putting in the appropriate number of hydrogens on each carbon to make sure each carbon has 4 bonds. And there we have it. I would like you to try to draw the following aldehydes. So stop the video. So methyl propanal, 3 is propanal. Put the CHO group on. Then put a methyl group on. And now put the appropriate number of hydrogens, so each carbon has 4 bonds. Next one, you've got a propanal. So 1, 2, 3, put the CHO group on. On carbon number 2 we have a methyl group. On carbon number 3 we have an iodine. And on carbon number 2 we have a hydroxy. Put the appropriate number of hydrogens on so that each carbon now has 4 bonds. Next one we have a butanal, so 4, 1, 2, 3, 4, put the CHO group on. On this one we have a methyl on carbon number 2. We have a hydroxy group on carbon number 2. We have a chloro on carbon number 3. Now put the appropriate number of hydrogens on so that each carbon has 4 bonds. Now we're going to look at ketones. The first member of the homologous series of ketones is propanone, better known as acetone. So ketones also contain the carbonyl functional group, but this carbonyl functional group is not on the end. So it's on any of the middle carbons. So this is the first member of the homologous series of ketones, and this is known as propanone, O for ketone, and its most common name is acetone. This one here is the second member of the homologous series of ketones, and you can see there are 4, so it would be butanone. Now at this point in time we don't have to specify the location of the carbonyl group because it can only be in one position, carbon number 2 for a ketone. At this point though you would need to, because the ketone group could be on carbon 2 or carbon 3. So this one would be pent, tan, 3. 2-O. When naming a ketone, the most important functional group becomes this ketone, the carbonyl group, and the carbonyl group must be in the lowest possible position. So it could be 1, 2, 3, 4 or 1, 2, 3, 4. So going this way puts the carbonyl group in a lower position. So we have to name the parent chain, which is butane, because it's single bonded. And on carbon number 2 we have the ketone group, so it's a butane 2O. Now we have one branch here with one carbon in it, so it's a methyl. So we go methyl, and that's on carbon number 3. And then we have a bromo and a chloro, and they need to go alphabetical. So it's a chloro, carbon number 1, and a bromo on carbon number 1. So this compound is 1 bromo, 1 chloro, 3 methyl, butane, 2O. Now I'd like you to try naming these ketones. Remember to stop the video and have a go. So this one here, this is the carbonyl group. We need this in the lowest possible position. So this is butane 2O. Try this example. Remember to put the carbonyl in the lowest position. Stop the video. Have a go. 1, 2, 3, 4, 5. This is the most important group, so it's pen, tan, 2O. We have a branch here with 1 carbon in it, so it's a methyl. We have a bromo, and we have a hydroxy. So methyl is on carbon number 3. Now bromo and hydroxy are both functional groups in prefix. So B goes before H. So it's hydroxy on carbon number 5 and bromo on carbon number 3. So 3 bromo, 5 hydroxy, 3 methyl, pentan 2. Now try this example. Stop the video. Carbonyl group needs to be on the lowest position. So 1, 2, 3, 4, 5, 6, 7. So it is a heptan 3O. We have a branch with 1 carbon in it, so it's a methyl. And that's on carbon number 5. And that's it. So, oh wait, and a chloro. Almost missed it. Chloro, which is on carbon number 4. So 4 chloro, 5 methyl, heptan 3O. Drawing's always easier. Draw the main parent chain first. So in this case it's pentan 2O. So 1, 2, 3, 4, 5. There's the 2O. We have 3,3-dimethyl, so there's 1 methyl, there's another methyl. We have 1 hydroxy, and we have a 4 chloro. 1, 2, 3, 4. Now complete carbon bonds by adding in hydrogens, so that each carbon bonds 4 times. Now try drawing these ketones. Stop the video, have a go. Octan 2O. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 2. Now complete carbons bonding by putting in hydrogen so that each carbon bonds 4 times. Next one, pentan 2O. 1, 2, 2, 3-methyl. Now complete carbons bonding by putting in hydrogen so that each carbon has 4 bonds. This is a long one. Heptane-threone. 1, 2, 3, 4, 5, 6, 7. There's the ketone, 4-methyl, 1,2-hydroxy. Complete carbons bonding by putting in hydrogens so that each carbon bonds 4 times. Now go to the OneNote and try some naming and drawing yourself.